Hello everyone. My name is Priyanka Gharat, working as a design verification engineer at Silicon Interfaces. This presentation is done by help of my colleague Mr. Karthik Bandaru and under the guidance of Professor Shastri. As we all know that functional coverage plays a very vital role in a verification environment. So over here, I'm going to present that how to attain a maximum functional coverage with the help of automation tool. All this has been explained with a very interesting example that is Zetta Hertz high-speed CDMA transceiver. As I said, this presentation is done with the help of my colleague Mr. Karthik Bandaru, then under the guidance of Professor Shastri and myself. So there are total 4 goals in this session. In first, we are going to see that how the standard simulation doesn't help us to achieve an optimal coverage goal. And second, we are going to see the steps, that is, which part of UVM we are going to import in EDA tool to attain a maximum coverage. Third is the process of EDA tool in detail and later on how it identifies the hidden bug to achieve a maximum functional coverage with the help of least simulation cycle. Last is to cover the automation tool coverage report with the standard simulation report. Let me take you a glance idea regarding the example that we have used to attain a maximum functional coverage goal. So the design components of Zetta Hertz transceiver are bus interface, CDMA baseband signal generator, and PRBS sequence generator. A pictorial representation is seen on the left-hand side for a block diagram of Zetta Hertz. It consists of DUT and UVM CDMA. And the detailed representation of the Zetta Hertz is seen on the right-hand side. There are 2 blocks. One is transmitter. In transmitter, the 2 blocks generate the signal. One is a baseband signal generator and other is CDMA signal generator. Both the signal are clubbed and modulated so that the modulated signal is sent to a receiver part through a wireless modem. The receiver block demodulates the signal and tries to get the same signal which is being generated in the transmitter. Over here is a pictorial representation of a hierarchical structure of UVM used. It is same as a UVM based environment verification environment. Over here we are trying to use a scoreboard and an agent inside an environment. In scoreboard we are trying to use cover points which will cover the whole scenario, and in the agent we are trying to use the like monitor, driver and sequencer. The agent tries to communicate with the DUT through an interface. This is a UVM-based sequence item. In this, we are trying to use few signals to cover a scenario. And based on the signals, we are trying to add cover points. To cover these points, we are adding few functions. After running the sequence item and scoreboard, with the help of standard simulation, we are able to achieve the coverage report as seen. In this coverage report, we can see that only 3 of the test cases have been covered fully. But what about others? Others are not covered as expected. So to cover all the scenarios, we are trying to make use of automation tool. The process of the automation tool will be explained by my colleague, Mr. Karthik Bandaru.
Thank you, Priyanka, for giving a brief explanation about the standard simulation of Zetta H CDMA transceiver. As we can see here, only few of the scenarios has been covered fully, and remaining all are not covered. I'm going to show you how we can make the coverage maximum by using the automation tool. Next slide. To achieve a maximum functional coverage by using the standard simulation verification. Either we have to write a number of test cases or difficult constraint to cover the corner scenarios and maximum scenarios. But by using automation tool generated sequence, we are going to cover all the scenarios with a single sequence item. This automation tool is going to generate a systematic sequence for achieving the goals. This is going to give a results with a 10 to 100 times faster than the constraint random verification. Next. This is the automated sequence which is generated by the automation tool. Here we can see the sequence is extended from the base sequence which is UVM test bench. And we can see the task body where the scenarios are going to be transferred and in a flow of the test scenarios. Here we are going to plug in this sequence into the UVM test bench and overriding using the UVM the generated sequence into the UVM test bench. We are going to simulate the UVM and the results will be like a slide. Here we can see the whatever the uncovered scenarios has been covered generated sequence simulation. And downside we can see the scenario flow where green and yellow are the critical paths and red are the corner paths. By using the automated generated sequence, we are going to cover the corner cases also. By this, the bugs which are in paths also will be found and eliminated. See the process of the automation tool. There are two blocks in this slide. One is specification and one is execution block. In specification block, we are going to take the SV coverage and the sequence item with the user defined constraints and some cover groups. Based on this cover groups and constraints, tool is going to generate a coverage strategy and PSS model. This coverage strategy and PSS model will be used for the generating automated sequence. And the sequence we are going to plug in into the UVM test bench and we will send the stimulus to the DUT through the driver in execution part. By seeing this coverage report, we can conclude that the automation is going to generate a sequence which will cover all the scenarios and will give the maximum coverage reports. This will help us to find the bugs in earlier process of the verification environment. This will limit the reruns in the expensive FDSOA technology.
Thank you.
Thank you for your time.